Hi everyone, in today's video we will discuss everything about the concept of quicksort technique. So quicksort is one of the sorting technique where we sort the elements of an array by applying divide and conquer approach. So what divide and conquer approach says? Divide and conquer approach says if you have a large problem and if it is difficult for you to solve that problem, then divide that problem into two sub problems. And that's what we had done in the case of merge sort and in the binary search. Okay, in those two algorithms as well we had applied the divide and conquer strategy, and here as well we will be applying the divide and conquer strategy to divide the entire problem into two sub problems. And for dividing the entire problem into two sub problems, we will be finding the partitioning index, that is the position of the sorted element. So for determining the partitioning index, we have to use the concept of pivot, and we will be declaring the first index of the problem as the pivot element, and we need to bring the pivot element into its sorted position where all the elements on the left side of the pivot element will be lesser than the pivot element, and all the elements on the right side of the pivot element will be greater than the pivot element. As you can see here, just for the sake of proper understanding, I have adjusted the pivot element into its sorted position here. Okay, so that you guys will get a better clarity here. Okay, so now we have to consider this first element as the pivot element, and we have to bring this pivot element into its sorted position, and that position will become our partitioning index. Okay, so when we adjust the pivot element into its sorted position, then all the elements on the left side of the pivot element must be lesser than the pivot element, and all the elements on the right side of the pivot element must be greater than the pivot element, as you can clearly see here in this example. Okay, so 25 is the partitioning index, and all the elements on the left side of the 25 are lesser than this number, and all the elements on the right side of 25 are greater than this partitioning index. Okay, once we find out the partitioning index, what we can do is we can apply the same quick sort technique recursively on the left sub problem from low to j. Suppose this, consider I have j. Okay, j minus 1 from low to j minus 1, and from j plus 1 to high. Okay, so like this we need to keep on making a recursive quick sort call on both the sides to calculate or estimate the partitioning index on each of the subproblems, and we used to keep on sorting the elements. Okay, so just for the sake of understanding, I have written this example, these numbers in this manner where the element 25 is in the sorted position. Okay, so now I will clear these numbers and then I will start applying the quick sort algorithm on this problem to sort all these numbers using quick sort technique, which follows the divide and conquer approach. I'm sure you guys have now understood the concept of quick sort, and I'm going to apply the concept of quick sort on this problem to sort these elements. Okay, so now first I will mark the first index as low and the last index as high, and I have taken an additional index of infinity just to indicate the end of the list. Okay, so now here you can see I have to consider the first element as the pivot element. So this is my pivot element. Okay, so now I need to check, is there any element greater than the pivot element on the right side of the pivot element? Then we have to send it on the right side, and similar thing we have to do on the right side. If I find any element lesser than the pivot element, then we have to bring that element on the left side. Okay, so that I have to done with the use of two pointers I and j. So I will be maintaining a pointer I which will be pointing to the pivot element, that is on the first index, and I will be maintaining a pointer j which will be pointing to the last index, that is j. Okay, so whenever I find an element greater than the pivot element on the right side of it, and whenever I find an element on the left side of j which is lesser than the pivot element, then I will be swapping those two elements. Okay, so now let us start solving this problem. Okay, so first I have marked this first index as I. So I will check, is there any element on the right side of I which is greater than the pivot element. There is an element 10, but 10 is not greater than pivot element. So what I will do, I will check in the next index. So we have 72 in the third index, and that 72 is greater than the pivot element. So what I will do, I will mark 72 as I. Okay, so now I have found the greatest element on the left side of the problem. Okay, so now I will move on to the right side. Here I will check, is there any element on the left side of J which is lesser than the pivot element? Yes, there is an element 9, and I will mark this 9 as J. Okay, so now what I will do, I will replace I and J. So I will put 9 in the place of 72 and 72 in the place of 9. Okay, and all the other elements I will keep as it is. 10, 18, 40, 11, 32. Okay, so now the highest element of this problem has moved to its sorted position. Okay, so now again I need to apply the same concept on the rest of the elements. Okay, so again I will consider this as a pivot element, and now our I was on this position and J was on this position. Okay, again I will check, is there any element on the right side of I which is greater than pivot element? There is an element 18, but it is not greater than pivot element. So what I will do, I will check in the next location, and the 40 is greater than the pivot element. So what I will do, I will mark 40 as I. Okay, and I will move on to the right side. Here also I will do the same thing. I will check, is there any element on the left of J which is lesser than the pivot element? Yes, on the left side of J we have 32, but 32 is not less than pivot. So I will move further ahead and I will check with the 11. So there is an element which is 11, and that 11 is lesser than the pivot element. So what I will do, I will mark that element with J. Okay, so now what I will do, I will swap these two elements. I will put 11 in the place of 40 and 40 in the place of 11, and rest of the elements I will keep as it is. 25, 10, 9, 18. Okay, and then 32. Next is 72. Okay, so now in this case our I will be pointing to the 5th location and J is pointing to 6th location. Okay, so now again I need to apply the same concept. I need to check, is there any element on the right side of I which is greater than 25? Yes, 40 is greater than 25. So what I will do, I will point 40 as I. Okay, and from this side I will check, is there any element on the left side of J which is lesser than the pivot element? Yes, there is an element 11, and the element 11 is lesser than the pivot element. So what I will do, I will mark this 11 as J. Okay, so now you can clearly see here I has crossed J. So whenever I crosses J, you need to replace the element whichever J will be pointing to with the pivot element. Okay, so whichever element J will be pointing, you need to replace that element with the pivot element. Okay, so what we will be doing is, we'll put 25 in the place of 11. Here it's 11. Now what we'll do, we will put all the elements as it is: 10, 9, 18, 25, 40, 32, 72. Okay, so now you can see this was our pivot element. Okay, and now the pivot element is in its sorted location, and now this location we can call it as the partitioning index, where on the left side of this partitioning index all the elements lesser than the pivot element, and all the elements on the right side are greater than the pivot element. Okay, so but all these elements on the left side are not sorted, and all the elements on the right side are not sorted. We have to still apply recursive quicksort technique on the left side as well as on the right side to sort these elements. Okay, but the element which is the partitioning index element is now sorted. Okay, so now we have to apply the same quicksort recursive call on the left side of the partitioning index, starting from low to, consider this as J to J minus 1. Okay, till here, and we have to again make a recursive quicksort call on the J plus 1 to high. This is our high, J plus 1 to high. Okay, now let us apply the same concept on the left sub problem. Okay, so let us consider this 11 as the pivot element, and I will mark this 11 as I. Okay, and then I will consider this j. Okay, so this is our last element. So now what we will do is we will check, is there any element on the right side of the pivot element which is greater than the pivot element. 10 is there, but 10 is not greater than pivot element. 9 is not greater than pivot element, so we will move to the next element. And 18 is greater than pivot element, so what we will do, we will point 18 with I. Okay, and j is here. I will check, is there any element on the left side of j which is lesser than the pivot element. There is an element 18, but 18 is not lesser than pivot element, so I will move to the next. Yes, this 9 is lesser than the pivot element, so I will mark 9 here. Okay, so now you can see I has crossed j, and I have told you that whenever I crosses j, whichever element j will be pointing, that element needs to be replaced with the pivot element. So now we will put 9 in the place of 11 and 11 in the place of 9, and all the elements will be kept as it is. Okay, and 25 will be in its sorted position. So now you can see all the elements on the left side of the partitioning index are now sorted completely, and we have to apply the same quick sort recursive call on the right side of the partitioning index, exactly the way we had applied it on the left side. Okay, now at this time, whenever we will be applying the quick sort on the right side of the partitioning index, we have to start from j plus 1. So this was our j, and now this is our j plus 1. Okay, j plus 1, from j plus 1 to high. So again we have to apply the same concept. We have to consider this 40 as the pivot element, and I will mark it as I, and this was our high, and I will mark it as j. Okay, I will again check, is there any element on the right side of the pivot element which is greater than the pivot element. No, 32 is not greater than, so I will move to the next. Yes, 72 is there. 72 is greater than the pivot element, so what I will do, I will mark 72 as I. And I will check from the right side, is there any element on the left of j which is lesser than the pivot element. Yes, 32 is lesser than the pivot element, so what I will do, I will mark 32 as j. So now in this case as well, I has crossed j. So, and I have told you, whenever I crosses j, we have to replace the element pointed by j with the pivot element. So we have to bring 32 in the place of 40. 32 will come here, and 40 will come here, 72 will be here. Okay, so now you can see all the elements on the right side of the partitioning index are now completely sorted, and we have completely sorted all the elements on this large problem, and we have applied recursive quicksort approach on both the sides to sort these elements. Okay, so I am sure you guys have understood the concept of quicksort, and that's all the explanation on the quicksort technique. Okay, and that's all for this lesson, guys, and thanks for watching.